Welcome, my name is Aldri Favariski and I'll be presenting about nuclear power plant vapor system. On this presentation, I'll be talking about how vapor systems work, how nuclear power plants work, the types of nuclear power plants, and the effects and causes of nuclear power plant failure. Let's start with vapor systems. What is vapor system? Vapor system is a system that uses steam, the vapor in this case, to generate electricity. The way it generates this electricity is the steam would turn a turbine which is connected to an electrical generator. Where does the steam come from? The steam comes from the boiling of water. Now, the boiling of water doesn't happen at normal temperatures, not like you're doing it in the kitchen. However, it does it at a high pressure environment, which causes the water heat to be able to be heat up at a higher temperature rather than its normal boiling temperature of 100 degrees Celsius. This allows the steam to have a higher pressure, which generates electricity. So how does a nuclear reactor take advantage of this system? Well, a nuclear reactor uses something called nuclear fission to generate the heat necessary. A nuclear fission is a process of splitting an atomic nuclei into smaller nuclei. The effort of splitting it into smaller nuclei generates energy. This energy would then be used to heat up the water. To boil the water, the fission needs to occur continuously to release a constant stream of energy which will constantly heat up the water. There are several types of nuclear reactors and how they uh, use this nuclear fission to generate electricity. According to the World Nuclear Association, there are six types of nuclear reactors. They are pressurized water reactor, boiling water reactor, pressurized heavy water reactor, advanced gas-cooled reactor, light water graphite moderated reactor, and fast neutron reactors. A pressurized water reactor uses water that is pressurized at 150 atmospheres, which heats up to 325 degrees Celsius to boil water. Now, the high pressurized water itself doesn't boil, but instead it is used to boil the water in the heat exchanger chamber, which turns it into steam. Now, after it exchanges the heat with the water, it then goes back to the pump, which goes back to the reactor chamber for the process to repeat again. An example of this kind of reactor is the 3 Mile Island reactor in the United States. Next, we have the boiling water reactor. Unlike the pressurized water reactor, a boiling water reactor boils the water in the reaction chamber rather than in a separate chamber. So in here, uh, this causes it to be able to operate at a lower pressure of 75 atmospheres, and the water boils at 285 degrees Celsius, which would go to the steam, which would go to the turbine to be generated. An example of this of a power plant that uses this type of reactor is the Fukushima Daiichi reactor in Japan. Next, we have the pressurized heavy water reactor. or also known as can-do reactor, which is used in Canada and other places such as India and France. This kind of reactor works exactly the same as a pressurized water reactor, except it uses heavy water or deuterium oxide instead of normal water. The heavy water is pressurized to 100 atmospheres heat and is heated up to 290 degrees Celsius before going to the heat exchanger to boil the water there. An example of this is the Darlington Nuclear Generation Station in Canada. Next, we have the Advanced Gas Cooled Reactor, or AGR. Unlike the first three, AGR uses carbon dioxide gas to boil the water. Now, the carbon dioxide is circulated in the reactor chamber, which heats it up to 650 degrees Celsius, which would then boil the water in the pipes that leads to the steam, which leads to the turbine. The water itself at that high temperature would turn to steam. The example of this type of nuclear reactor is the Calder Hall Nuclear Power Station in Britain. Next, we have the light water graphite moderated reactor. This type of reactor works in the same way as a boiling water reactor. However, it has a downside of a lack of a safety precaution. In a light water graphite moderated reactor, if the water were to be boiled excessively, the cooling on the fuel rods would be reduced significantly, which could lead to a meltdown. An example of a reactor that uses this is the Chernobyl reactor. And lastly, we have a fast neutron reactor. A fast neutron reactor uses, fast neutrons that are available in plutonium to maintain fission instead of using slow neutron reactors such as uranium, which most of these use uranium. Knowing how these these reactors work, how does a meltdown occur? Well, as I've explained in the light water graphite moderated reactor, a meltdown could occur when the fuel rods are not cooled enough. If it were to overheat, the the react because it keeps on giving out energy as heat, it will melt down the reactor chamber, which could cause it to leak radioactive material. This is what this is what happened in 3 Mile Island, Fukushima, and Chernobyl. In 3 Mile Island and Chernobyl, the causes of this meltdown was human error. Both lacked safety precautions. Well, not safety precautions, more of safety protocols that they lacked. Meanwhile, on the Fukushima disaster, it instead was caused by an earthquake damaging the electrical grid of the cooling system, which causes the fuel rods to not get cooling, which melts down the reactor. Now, apart from it spreading radiation, a nuclear a reactor meltdown could also lead to explosions and fires. This concludes my presentation on nuclear reactors. Thank you so much for watching. and see you next time.